Okay, so here is my simple code. So, and this is based on what Jordan Ellenberg had written. So I pick a size for my grid. I make a table that's a little bit bigger. So if I'm going to study the circle of radius 4, I'll make the table a 6 by 6 table. And I'm using zeros in a grid for wins and ones in the grid for losses. Okay. So what I do is we do a for loop and we start at the end, n plus 2. We start at n plus 2 and we count down I minus minus till we get to 1.
All right.
And then we for the i's are going to be the x coordinates, say, and the j's are the y coordinates.
Okay.
And then what I do in my for loop, counting backwards, like we were talking about, although this is going backwards, you know, rows and columns. But it's still, you see that going backwards was a good strategy. So the first thing I did is I check either if I squared plus j squared is greater than or equal to n squared. So what's that checking?
It's checking if it's inside or outside the circle.
Yeah, and it greater than or equal to means that there was one other possibility.
Right, so it's actually on the circle.
Okay, and then I check the three other cases. I plus 1 squared plus j plus 1 squared is greater than n squared. What am I checking here?
So
Is
that's if you can get out in one move.
That's basically.
Yeah, and which move was that?
That's the diagonal.
Diagonally.
Move.
Okay, and then I check I squared plus j plus 1 squared and I plus 1 squared.
There's the vertical and horizontal.
Okay, so either if I'm on the grid or I can move out of the grid, I keep that grid point at 0, because that's a win.
That's a win.
Okay. Otherwise, I look at the maximum value of the grid points I can move to.
Mm-hmm.
And if the maximum value is a 1, in other words, a loss, so if I can move to a loss, I set that to be equal to a win. And if the maximum value isn't 1, that's the other choice in the if statement.
It becomes 1.
It becomes a 1. If the maximum value is 0, in other words, if I can only move to points where my opponent will win, then I lose. So if I run this with the 4x4 case, the ones are yellow.
So I guess it's sort of, is it doing it in reverse?
Yeah, so
Circle would
that
be
actually, yeah, and again, me just being a little lazy, I didn't go to 0, 0. So this is the 1, 1 grid point. For the picture, let's shrink it. So this is the 4x4 case.
All right.
Okay. Maybe we should look at the 6x6 case that we did.
So looks like
And
we
then
did find.
we did the 7x7 case. Because we went from 0 to 6. It looks like.
Well, we did
Just excluding.
we did the radius of the
these
circle
two
was
rows.
6.
Mm-hmm. We had 7 dots.
Yeah, we had 7 dots, but here the size of the n is being used as the radius of the circle. If I extended this out, what would happen if I made the grids bigger? They would always be outside the circle.
Yeah.
Right? Okay, so now we'll look at what you tell me a size you want to look at.
Maybe 15 by 15.
Okay. What are you expecting to see in the 15 by 15?
Probably a lot more losses, because you have a lot more points that are going to be inside the circle, so that means you're going to have more losses. Yeah.
Okay.
It's sort of like these almost rows going through the middle, and then there's just scattered points on the ends.
All right. Yeah, you pick a size now.
Let's do, I don't know, let's go big. Let's go like 100.
Okay. 100. All right.
So
Tell me.
it's starting to trace out the circle almost.
It's like, yeah.
Yeah. So tell me what you see here. What are some of the
We're getting like,
things you see?
I guess kind of like, you got these concentric rings.
The yellows are losses.
Mhm.
Yeah.
And then it looks like overall you're starting to get more losses than wins. Or
Inside the circle?
maybe about the same amount of losses and
Oh,
wins.
that's a great
Inside.
question. We could actually write a program easily to track that
The number of losses and wins.
inside the circle. Yeah.
You're also getting, like, in the center, this one big shape of just rows upon rows. It's like alternating losses and wins, almost. It's going like
Yeah.
that.
So there's actually a little bit of structure that's starting to show up, which is interesting. So what? Give me another size.
Maybe let's go to 1,000. I don't know if you'd be able to see the individual colors at that point.
Yeah. Well, we'll take a look.
I'm gonna take a little bit to run.
Yeah. Why does it take so long at 1,000 compared
Because
to
we're
100?
running too many for loops.
Yeah.
So we are starting to trace out. You can see it's just like slightly behind this corner and that corner up there.
Uh huh.
So you can't really see the individual dots anymore.
Yeah. But what can tell me some things you do see?
You can see that it's an individual, like it's a circle. It's getting traced down. It looks like here's like primarily yellow, and then over on the edges it's a bit more
You do.
purple and yellow.
You see, like, we saw the same shape in the hundreds. We
Kind
saw
of
this
diamond shape.
diamond with the very edge cut off.
Uh huh. Do you see any other structure?
There's like, I don't know, there's like some sort of curve going up here. It's kind of got a checkerboard pattern.
Yeah.
Lions coming out of the diamond.
Mhm.
Almost.
Do you see any other curves?
You've got like, I don't know, like these kind of curve off. You kind of a curve like here and there.
Yeah, there's starting to be some pretty surprising. It's not making like it's not making a structure we've seen before. Like it's not making Sierpinski's triangle or something like that, which would
That'd be weird.
that'd be pretty weird. But there is some structure here. Maybe if we back off maybe to 500. I've never even looked at 500, but maybe we'll see a little bit more structure of the structure there. Oh yeah.
Yes, there's definitely some like lines and curves going on.
Yeah, and you can see some of those checkerboard patterns still that you were talking about. So I think in this situation, do you think there's like a function or some formula that if I told you ahead of time, here's a dot, here's a grid point, tell me if I win or lose? Do you think there'd be a function that could tell you?
It doesn't look like it because it looks like it's very different in each kind of general area.
Okay.
Like in the center, it almost looks like it's like guaranteed.
Well,
Or maybe
it is-
50-50.
It's a 50-50 chance
'Cause
because
it's like-
in each of those, between each of those yellow rows, there's a purple row.
Okay.
But then like out here, like if you like throw a dart here, how do you know? Like how can you predict what it's going to be? It's kind of the pattern keeps shifting.
Yeah, it's certainly very interesting. Like, and maybe because it actually would be very easy to count the wins and losses inside the circle, maybe we could see it. Does it approach a constant? That might be a fun thing to look at. That's a neat idea.
Yeah.
All right, what do you guys think of this game?
I think it's pretty
Pretty
neat.
cool.
All right, well, cool. Hey, high five. Good job, guys.